Hey guys, it's me again. I am going to show you how to find the SD with a shortcut, as I promised you I would. But first, I want to talk about the box model that you set up for number 5 before we get into the SD shortcut. So hopefully when you looked at number 5, you understood that the 80% tied with the prize of not winning anything. And then the 10% was aligned with the $1 prize, 7% chance with the $2, and 3% with the $3, right? So if you think of the box model, there's going to be 100 tickets. Well, you can set it up multiple ways, but I think it's easiest to do 100 because we're working with percents, right? And percent is out of 100. So 80% means I'll have 80 of these tickets. Well, what am I winning? So there's an 80% chance I'm going to win nothing, right? So because we're wanting to know the total amount we win. So this is where we want to put the actual money amount on the ticket. So 80% chance we get nothing. And then we have a 10% chance that we win $1. So 10 of the tickets have $1. 7 of the tickets have $2. And then 3 of the tickets have the $3. So then if you add up the total number of tickets, it adds up to 100. And then what's on the tickets is the money that we would win, okay? So then the draws from that box model is how many customers, hold on, come on in. Sorry, had Allie come and say hi. Anyway, so we have 50 draws because of the 50 customers, right? And they're wanting to know the chance that they pay out more than $20 in prizes. So if 50 people are buying these scratch and win cards, then we need to draw a ticket, and then we're going to sum up those 50 draws, or the 50 people, right? So then we need to find the average of the box and the SD of the box. So the average of the box, right? If we did 80 times 0 plus 10 times 1 ticket plus 7 tickets. Anyway, and we did this, we divided it all by 100, then we would get the average. So 10 plus 14 plus 9. Right? Hopefully I don't make any mistakes here. So 33, I think, which is 0.33. Okay, so that's the average of the box. Now the SD, to find the SD, we'd have to put 100 numbers in our list, which would be a pain in the butt. So I'm just going to tell you the SD because there won't ever be a question that you'll have to, like this one, that you'll have to find the SD in a list. So the SD here is 0.74. Okay, so now that we have the average and SD, can we find the EV sum and the SE sum? So the EV sum will be the average of the box times the number of the draws. So therefore the average of the box is 0.33 times the number of draws is 50. So a third of 50, of course I can't do mental math, whatever that is. SE sum formula is the SD of the box, times the square root of the draws. So then the SD of the box is 0.74 times square root of 50 So I'm going to pause for a second to plug these in. Hopefully you're plugging them in too with me. All right, so 0.33 times 50 is 16.5. And then 0.74 times square root of 50 is 5.23. Okay, and this is money. So I'm going to put a dollar sign there. All right, so what this means is we are expected with the 50 people to get $16.50 in prizes, give or take the $5.23. So now we're going to use that information to answer what the question really wants, which is find the chance the store has to pay more than 20. So if we're looking at the normal curve, right, the expected value is right here, 1650. And then this would be 1 SE, 2 SEs, 3 SEs. So then if we add $5.23, that value is going to be right here, which is what, 2173, I think. So if we're wanting the probability pays more than 20, well, it's going to be about, sorry, this is kind of sloppy, about right here, and then all of this area is what we are trying to find. So with the norm CDF shortcut in the calculator, which is menu 652 with the TI Nspire, the lower bound will be the $20 because we're wanting what is the chance they pay more than the 20. So the lower bound's 20, and the upper bound will put a high value of 10,000. And then our mean is our expected value, which is 16.5. And then our SD is our SE, which is 5.23. Is it gonna let me write? Okay. All right, so when we plug that in, I also wanted to show you another way to do the norm CDF where it will actually shade the area of the normal curve that you are finding. So from the home screen, you can just open up a new document and then select lists and spreadsheets, so option 4. And then right here, just in an empty cell, select menu 422. So menu 422 will do the normal CDF like we do in the calculator page. So let's see, my lower bound was 20, right? My upper bound was that high value of 10,000. And then my expected value was 16.5. And I can't remember the standard, 523. Okay. So then, and then right here is where you actually click on the shade area and click OK. And then that's where, let's see, my screen's hiding it, but that's where it actually shades the part of the normal curve. And then it also tells you the area under, can't see it because my thing's in the way. But anyhow, so it will tell you the area, and it also tells you here in the spreadsheet what the area is. So 25% of the time, they would pay out $20 or more. So this equals 0.25 or 25%. Okay. So again, if you want to see the shaded curve, just go into lists and spreadsheets, and it's menu 422 if you want to do that. Otherwise, it's in the calculator screen, menu 652. Okay, so that was example 5. And let's look at 6. This video hopefully won't be too long. It might be though. All right, so number 6 says there's a 15% chance that a randomly selected person has a particular gene, And if you take a simple random sample of 1,000 people, what is the chance that fewer than 140? So let's just set up a box model that shows those people that have the gene, okay? And there's not just one correct way to set this up. But like I did before with percents, I think it's easiest to make it out of 100 tickets since percents out of 100. So I would do 15 have the gene, so 15 of them have 1 on the ticket because we're counting those. And then the remaining percentage of people, which is 85, do not have the gene, which would be 0, right? So that would be 15% have it, 85% do not, and we're only counting those that have it. So then if we take a simple random sample of 1,000 people, how many do we expect to have it? So without finding like the average of the box and then doing the formula with EV sum and all that, not that that's bad, but I think sometimes it's good to just use common sense, right? If there's a 15% chance of having the gene, then what's 15% of 1,000? So then that should be 150, right? 150 people we expect out of the 1,000 because it's just 15% of 1,000. So the average is the 0.15 or 15%. So therefore the EV sum is that average times 1,000, which is really what you do if you find 15% of 1,000. It's the same arithmetic. So 150. Okay, so now I'm going to show you how to find the SD when we just have 2 numbers in your box model. So on your formula sheet for your exam, you have, internet's going crazy. Okay, you have this formula. So the SD shortcut is the large number on the tickets. This is on the tickets. Oh, my hand was in the way, sorry. And so the large number that's on the tickets minus the small number on the tickets times the fraction of them. So let me explain that. So if we go back to this example with the gene, oh my goodness.
Good afternoon, all. If you haven't grabbed a half hour for lunch, probably a good
So I had
time to do
Mr.
so at
Peterson.
this time.
What's up?
Thank you very much.
I'll do it, Ms. Carson.
So I don't even know what I was talking about because I'm getting all sorts of visitors, which is fine, but SD shortcut. So the SD shortcut should be the large number on the tickets minus the small number. So here it would just be the 1 minus the 0, which is just 1, and then times the fraction of each of them in the box. So you can do the fraction or you can do the decimal. It wouldn't matter. So 15 out of 100 are ones times how many are zeros is 85 out of the 100, right? So then that really is going to be the same as just the square root of 0.15 times 0.85. Should be probably like 0.3 or 0.4 is my guess. Let's see. 0.36, I guess, if we round. Okay, so 0.36 is the SD. So that's a lot faster than putting in 15 ones in a list and 85 zeros and doing menu 411, because that would be crazy. So remember, you can use that shortcut when you have just 2 numbers in your box model or two types of tickets. Okay, so then if our SD is 0.36, then the SE sum will be that SD times the square root of the draws So times 1,000. And then that will be the SE sum. And then from there, you do what is the chance that fewer than 140. So that, remember, if you're thinking fewer than 140, then on the normal curve, if we expect 150 to have the gene, give or take whatever the SE sum is, then we're finding wherever 140 is and the percent below that. So just make sure you put in the correct lower bound and upper bound in Norm CDF. So hopefully that will help you to do 6, 7, and then 7 you will also use the SD shortcut. And then number 8, I'll tell you what the SD is, because that's another one like the scratch and win cards. If I can. Okay, so number 8, the SD is 0.48. So use that. And this one, well, it's sort of weird because you have 75% chance of a single lamb, so one lamb, so that'd be 75% chance of having one lamb, right? Twins is 0.20, so 20% of having twins, 20% chance of having twins. And then no lambs is 5, so then you go 5 is 0, and that should be the box model, okay, with the 360 draws for 360 lambs. Anyway, but the SD is that, so you don't need to put all those numbers in a list. So I'm gonna post this, and then the answer key will be later, and let me know if you have any questions. Thanks for listening.